Okay, so in today's video, this is going to be a math for fun. So what we have is our double sum from a is equal to 1 to infinity and b is equal to 1 to infinity of 1 divided by a squared b plus ab squared plus 2ab. So let's get started. I'm actually going to let the capital S be our given double sum. Okay. And then I can actually factor out an AB from the denominator, so this can be rewritten. So this is A times B, then times A plus B plus 2, then its numerator is still 1. Okay, nice, so far so good. Now, one thing I would like to note is that our definite integral from 0 to 1 of x raised to the a plus b plus 1 dx. When we compute this definite integral, so we would get a plus b plus 1, then divide by that, so it's 1 divided by a plus b plus 2, then multiplied by x raised to the a plus b plus 2, and then evaluated from 0 to 1. Let me fix that 2 for a second. 0 to 1. So when we evaluate at x equals 1, 1 raised to any number is always going to be 1, so this is just equal to 1 over a plus b plus 2. And then when we evaluate at 0 for x, then x is going to be equal 0, so our value comes down to 1 over a plus b plus 2. So what this means is that we have this, we can actually substitute the integral for our 1 over a plus b plus 2 that's inside the double sum. So now, again, can be rewritten as the double sum again. Of 1 over a divided by b, integral from 0 to 1 of x raised to a plus b plus 1 dx. Okay, and now I can actually interchange. So meaning I'm actually going to move both the double sums inside of the integral. But this also means that what I'm also going to do now is I'm actually going to write x raised to the 1 as separate. Like I'm going to separate the exponents using our rules. So in other words, it's going to be written like this. To 1 of x, and then double sum of 1 over a times b, then multiplied by x a x b dx. And then again, I can rewrite this. Now I can actually interchange the sums, so the indexes match with the a's, and then the indexes match with the b's. So this is 0 to 1 of x, and then equals 1. So that means x to the a divided by a, then multiplied by, then x to the b divided by b dx. Okay, very nice. So now this way we have a product of the sums. So now what I'm going to do next is I'm actually going to replace both of the sums with our Taylor series expansion. So note that the Taylor series of ln of 1 minus x, that's equal to negative x minus 1/2 x squared minus 1 over 3x cubed, and then plus ... so on. So simply that Taylor series expansion can be rewritten as sigma from n is equal to 1 to infinity of negative x raised to the n divided by n. Okay, great. So far so good. So because this is positive and there's a negative, so pretty much simply we're just going to be replacing each of those, both of the summations with the negative of ln of 1 minus x. Okay, so then we replace this. I'm going to write it over here. Then this is the integral from 0 to 1 of x, then multiply by negative ln of 1 minus x, and then same thing again. And then when we multiply these two products together, negatives cancel out, so we just get positive. So this is the integral from 0 to 1 of x multiplied by ln square of 1 minus x dx. Okay, nice. And now the next thing I want to do is I actually want to apply the definite integral reflection identity. So we're going to be creating a, we're going to be replacing everything that's f of x for, then replace that with f of a plus b minus x. So it's mirrored. So this means this is going to be f of everything for x here is going to be replaced with a plus b, which is 1 minus x. So all the x's will be replaced for 1 minus x. So when we do that, this is going to be 0 to 1 of 1 minus x. And then 1 minus x is simply just ln square of x dx. Okay, and so pretty much this is going to be a integration by parts integral. So I'm going to let u equals, I'm going to write it over here actually. I'm going to let u equals ln square of x. So when we take its integral, this is, so du is equal to 2 ln of x, then divided by x dx. Then dv equal to 1 minus x dx, then v is equal to x minus 1/2 square. Okay, so now we can multiply u times v, then minus v times, or minus the integral of v times du. So that way we have, let's see, so this is x ln square of x, then minus x square ln of square x divided by 2. Yes, okay. And then minus the integral of, so this is 2 ln of x divided by x multiplied by x minus 1/2 x squared. So when let's actually evaluate this piece from 0 to 1, okay? So rewrite this again. Ln square x minus x squared ln square of x 2. Then I can factor out an ln square of x. And then this is, well, again, this is the same thing. This is the same thing as just like before. Divided by 2. Evaluated from 0 to 1. So when we plug 1 for x, ln square of x is just ln of 1 and then 0 and then square that 0 again. So everything here will be 0. Okay. And then minus, when we plug 0, ln of 0 diverges to negative infinity. But then in here it's 0 minus 0, so everything's 0, so minus 0, so this is equal to 0. So now all that's left is to calculate this piece of the integral. So I'm actually going to multiply this out. So this is, I'm going to put this over here. So 2 times, let me see, I'm gonna put negative 0 to 1 of, okay, so it's 2x ln of x divided by x, and then 2 ln of x, yeah, let me write it like, here, I'm gonna put it this way. Let me adjust the x. 2 times 2 divided by 2 is 1, so this will just be minus x squared ln of x, all divided by x dx. And that can be simplified down when we cancel the x. This is just 2 ln of x minus x ln of x dx. And now linearity, I can actually split the integral into 2. So this is simply, yeah, I'm leave it here. So I can split the integral into 2. So this is, let me actually call each of these, I'm going to call, well, first, let me split the 2 first and then define each of the integrals. So this is negative 0 to 1 of 2 ln of x dx. Distribute the negative, so that's a plus integral of 0 to 1 of x ln of x dx. Okay, and now I'm going to call this I1 and then this I2. So we're just actually adding the 2 together to get whatever this equals to, okay? So the first piece of the integral I sub 1 is actually pretty simple. So this is negative 2. I can move that out. I can move the 2 outside, so it's negative 2 times this integral. So this is integration by parts again. So you let u equals ln of x, and then du is equal to 1 over x dx. Then dv is equal dx. V is equal x. Multiply together, so negative 2. Then multiply by everything when we combine together, so it's x ln of x, then minus the integral of v times du, so x times 1 over x is just 1, so it's x, and then being evaluated from 0 to 1, okay? So that means negative 2 multiplied by, when we plug 1, x, 1 times the natural log of 1 is just 0, then minus 1, so that's negative 1. And then when we plug 0, so 0 times ln of 0, ln of 0 is actually negative infinity, diverges to negative infinity, multiplied by 0, 0, then minus 0, it's 0. So this means negative 1 minus 1 is negative 1, then multiply to 2, we get negative 2, okay? So that's our I sub 1. So now we need to find what I sub 2 is equal to. Alright, so I'm gonna go over here. So x, so this is again doing integration by parts again. So let u equals ln of x du equal 1 over x dx. Then dv is equal to x dx, and then v is equal to 1 over 2x squared. Yeah, okay. And then just combine everything together, so we get x squared ln of x, then divided by 2, right? Okay, and then minus the integral, so 1/2 x, so x squared divided by x, so that's just x on the numerator, and then divided by 2 dx, okay? And it's actually pretty simple to see that this piece is just 1/2 or 1 over 4 times x squared. So x squared ln of x over 2 minus 1 over 4 x squared, evaluated from 0 to 1. Okay, so that means when we plug 1 for here, this is 1 squared times ln of 1, which is 0, so that's 0. And then we plug 1 here, so this is negative 1 over 4. And then when we plug 0, 0 times So 0 squared is 0, then ln of 0 is divergence negative infinity, so 0 times that is 0, then plug 0 for 1/4x squared, that's 0, so this is just minus 0, and therefore when we calculate it we get negative 1/4, and that's equal to I sub 2. So now we have that, now we can just calculate I sub 1 plus I sub 2, 1 plus I sub 2, which is equal to, this is actually supposed to be a positive right here. That's positive. So this is 2 minus 1/4, which is actually equal to 7/4. So there we have it. Therefore, the double sum equals 1. B is equal to 1 of a squared b plus ab squared plus 2ab all 1 divided by that, that's equal to 7/4, like so. All right, pretty sweet, right? Double sums are awesome.